Oh. Anyway, okay. An object is pulled due south by, this is number one, by force F1 of 5N. Do you guys know what N stands for?
Newtons.
Newtons. So it's going down 5. And due east by a force of F2 12 newtons. That's what they're going to ask. Find the direction and magnitude.
That's a vector.
Okay, so if you add those two vectors together, the resulting vector is that. Anyways, what do they mean by direction?
Degree.
Yes. Remember that north was like 0 degrees, so they're kind of like asking for this angle. So we can figure this angle out right here, do 180 minus that angle to find the direction. And what did magnitude mean? Length. Length. So that would be,
Square plus b squared.
right, 5 squared plus 12 squared equals length squared. You guys have this one memorized by now?
13.
Yeah, so 13. So you do 5 squared plus 12 squared, square root of that, 13. So I'll call it vector F3. The magnitude is 13. All right. So how are we going to find this angle right here? Tangent, yes. Relative to this angle, we have the opposite and adjacent. So tangent of the angle equals opposite over adjacent. So what do we plug in the calculator? Tangent inverse. Probably rounding to like the 10th place or something.
67.4.
Is that the answer? Not quite. The direction is how many degrees are you from north. So how do I find this angle right here?
180 minus.
180 minus. So that'd be 102.6. All right.
112.
12.6. 112.6 degrees. I'll try again. 180 minus. All right. Remember too from years past that it always gives us troubles, but I'm hoping so. It's okay. In the diagram, AT colon TC equals 1 to 2. What does that mean? ATTC equals 1 to 2.
It's twice as big.
Yeah, basically TC is twice as long as AT. So do you guys see TC and AT in the picture? All right. Express each of the following in the form of RU plus SV. Okay, so U and V are vectors, right, that they drew in the picture. Vector U goes from B to A, vector V goes from B to C. So how could we get basically vector AB using those two little red vectors? That's basically what they're asking. How can we get a vector that goes from A to B? No.
Isn't it U?
Almost.
Negative U?
It's negative U. Because remember, the negative just makes it go backwards, right? Yeah, it's going the wrong direction. So, if you make it U negative, it would go from A to B. Okay, B is vector AC.
Is it 3?
So how can we get from, now, we're not talking about the length of the vector. By the way, those AT and TC are not 1 and 2. That's just the ratio. It could be like 5 and 10 or 10 and 20.
Would it be U plus V?
Close.
It's negative U minus V.
Also close. Okay, so we're trying to get from here to here. So how can we use these two vectors to do it? Well, we need to go here and then here, right? So how do I do this? We just talked about it. Negative U. And then I need to go that much
V.
V. So what would the total length be? Negative U plus V.
So close.
Just needed to combine that previous answer with that. C is vector AT. Well, yeah, it's just tricky. Okay, all these are kind of related to their previous answer. So that what we got on B would get us from there to there, right? Gets us all the way across. But on this one, we only want to go what fraction of the way?
1/3.
1/3. So we only want to go 1/3 of this. So it's like,
1/3.
I think they might have distributed the 1/3, but anyway, it's like that would do it. 1/3 of that vector.
So why wouldn't it just be on the V?
Because this altogether is this vector. And we only want to go 1/3 of that. So
Yeah.
together, those two together make the vector. It's like that plus that equals this.
He does not get it. I do get it.
Okay. Yeah, this one's always kind of tricky. Vector BT.
Negative U plus 1/3 V. Could it just be U? This isn't a test, is it?
No, not exactly, not like this, I don't think. Yeah, I don't know.
Yeah.
Well, okay, one way we could do it, this is trick, does anybody think they see it?
Is it U?
No. U goes from like here to here. And we gotta go from like there to there.
Z.
Okay,
1/3 negative U plus V. Yes.
okay, well, all these are kind of like based on the previous answer. So what we could do, remember we just found this one, right?
Yeah.
So if we do this vector plus that vector,
So is it
that would get us there.
negative U?
So it's
What?
negative this vector. Well,
Negative. Might just be.
I'm gonna distribute. The vector we just found was that one.
Yeah.
So if we do negative that vector and plus negative u. So negative that vector looks like that, and minus u looks like that, and then we could put those together. 1/3 minus 1 is negative 2/3.
No.
Yeah, it's tricky. Even I have to stop and think about it for a second. And I've done this before. But, over the course of a year, get a little rusty. All right. Number 3. A plane is on a course of 320 degrees at 480 miles an hour. Where is 320 degrees at? Almost 360, right? 360 is the same as 0. It's straight up. So 320 would be, well, not quite that close, but it'd be like 40 degrees short of No, yeah, second quadrant, I guess you could say. And the speed of the plane is 480 miles per hour. What are the north, south, and east, west components? Okay, the north, south component would be what? This one, east, west is this one. So I'll just call it X and Y for now. Okay, I put a little 40 right there. How did I know that was 40? Right. 320 is 40 degrees away from 360 from getting all the way back to the top. So if this is 40, how much would this one be right here? If this is 40, what's this? 50. Because this is a right angle right here. So those two angles have to add up to 90. Or you could say, remember, I don't know, you guys remember like straight left would be 270? Like it goes 0, 90, 180, 270, 360. So 270 is, the 320 is 50 degrees past 270. You can also look at it that way. Okay, so we have an angle and a side. How do I find these guys right here?
So good.
More sine stuff. So relative to 50, we're looking for the opposite. We have the hypotenuse, so that is sine of 50 equals opposite over hypotenuse. So what are we going to plug in the calculator? Nope.
Wouldn't it be y that we're trying to find?
Trying to find both.
Sine of 50 or
Sine of 50.
over 480.
No, how do we solve this?
Times 480.
Times 480.
Yes.
Wow, guys. You're in 11th grade.
I said the wrong answer and then you repeated. What are you trying to find y?
We're trying to find both. It's at the east, west, and north, south component.
So who's the stupid one for repeating a dumb answer?
I got it right.
To get rid of, this goes back to like 6th grade. To get rid of divide by 480, you multiply by 480.
367.7.
Okay, and then, so, that's basically how many miles per hour in the west direction they're going. I'll just say, yeah, I'll keep that miles per hour west. And then we need to find out how far they're going in the north direction. So that would be the y. So relative to this angle, y is the opposite. This is the oh shoot, this was the sine, my bad. Oops. Miles per hour north. Now I know what you're saying. Okay. So, screwed up here. This is the what?
It's going to be adjacent.
Adjacent over hypotenuse, so that would be cosine. So it's cosine of 50 is adjacent over hypotenuse.
308.5.
Miles per hour west. It's basically like your x and your y coordinate for that, but yeah. Alright, is it humid or is this just me?
Trying to load it.
Kind of feel a little sweaty.
It is true. Stop, please. No, you won't keep it.
No, you don't have to send me it. That's too much power for me to hold.
At least you know.
Yeah.
He knows his limit.
He knows he'd send it.
Okay, I'm kind of writing 4 down here, 0 and 8. Not really drawing the picture. Kind of drawing it, but not really what it looks like.
You could have all the power over
I already have power over the
They got some kind of blackmail material.
but even more.
I'll
I
be
think you have this.
Alright. So we're supposed to figure out the coordinates for D that will make this a parallelogram.
That's not parallelogram.
Well, there's only 3 points that we know, but we have to choose D such that it'll make a parallelogram. Now, here's the thing about parallelograms. The opposite sides are parallel and they're the same length, right?
Right.
So if we think of them in terms of vectors, like this vector would match this vector, and this vector would match that vector.
So could you just compare it to the other points and then just put in the answer?
Yeah, there's a bunch of ways we could do this. If I was doing it, I'd probably be like, how do we get from B to A, and then do that same vector to get from C to D.
Over 1 up 6.
Yeah, so the x values on B to A is going up 1, and the y value from -3 to 3 is going up 6. So it takes a 1, 6 vector to get from B to A. Put a vector form. So if we use a 1, 6 vector over here, what will point D? Where will point D be? 6, 6. Alright. Girls, did you catch that?
Yeah.
God bless.
Somehow I'm doubting your testimony. Number 5. Alright, we did this one
OT.
probably, I don't know, last Wednesday or so. Were you, Landon, you were probably gone for this, weren't you?
For the last Wednesday, yes.
Well, I'm guessing, I don't remember exactly what day. We only did a couple problems with the velocity and speed. I feel kind of bad about this, but I did put on the test. It's not hard to do, but since we didn't do a lot of them, it might be hard to remember. So let me back up for a second. There is something called a parametric equation.
I think we did that on Tuesday.
You think it was Tuesday? It looks something like this. Do you guys remember these? So 3, 4 is like the starting spot for your vector on the graph, and -1, 5 is like where it moves. Like left 1, up 5, that kind of thing. T, it kind of represents time, so after T is 1, it moves 1 of these. After T is 2, it moves 2 of these. You guys remember this? So it looked something like that on a graph, and you had to do points. Anyways, this directional vector is what they call the velocity. So on this problem, when they say, what's the velocity? It's just -1, 5. I'm taking my jacket off and you're putting your hoodie on.
Oh, it's cold though, so.
Yeah,
You're doing 5.
Yo.
there's a lot of girls like that. I have one in every class. just made that one up. My bad.
Uh,
That was just an example. Whoops. So what would the actual answer be on 5A? 1-4. Okay, now, but they also asked for what's the speed. What do you think they mean by the speed?
Distance.
Yeah, that means like how far are you getting in that vector? So basically it's like the magnitude. So how do we find the magnitude of a 1-4 vector?
Square left and then square right.
Yeah, it means 1 to the right and 4 up. So it's Pythagorean theorem. 1 squared plus 4 squared equals c squared. So it's the square root of 16 plus 1. 17. Square root of 17. Oh, yeah, I said that wrong. They called this one the vector equation, not the parametric. The parametric were when they separated the x and the y. So, how do we find the x?
Use
3 plus t.
3 minus
3.
3 minus t.
2.
3 plus negative t, negative 1t, or 3 minus t. And the y value is 4 plus 5 times t. Ugh. When and where?
There's a girl in every class do that too.
No, that's just this one. You can cover your mouth when you do that.
Did the kid cover when we just like filmed this?
I don't think we ever did 5C. Let's just skip that one. Okay, so
Let's not do the right one.
yeah, we'll leave that neither. There's 7.
2-day assignment. They both move.
2-day, we're almost done. And
2-day
probably
assignment.
It's not even an assignment, Leo. Not even an assignment.
that's well, it kind of is, but it's a give me assignment. Okay, number 7. Given the points, blah blah blah. Find the measure of angle A. Okay, there is a formula that will be given to you that we used on this lesson. You guys remember this? Cosine. What letter did they use? We'll say A. You guys remember dot product?
Yes.
Okay, whoops. I don't think I should. Dang it. Okay, so what does this mean?
Times.
Well, no.
dot product.
Not if it's vectors. They should probably use like vector
Is
symbols.
this dot product?
It means dot product, which means x value times x value plus y value times y value. Okay, what does this mean?
Magnitude.
Magnitude, which is the length of the vector, which is kind of like what we just did right here, right? 1 squared plus 4 squared square root of that. Okay, so this is how we find the angle. This formula will be provided, but you just gotta know how to use it. Okay, this is a little bit tricky because they don't just give us the vectors. All they tell us, I lost my place. Angle, or point A is at 130. I'm gonna draw a little fake picture again, kind of like I did before. So that's right there. B is at negative 2706. Was it negative 6 here? I forgot. 0, negative 6. Alright. So what we need to do first to find angle A is find the vectors that create those two angles. Okay, so if A is at 1, 3 and B is at negative 2, 7, what would this vector right here be? Okay, negative 3, positive 4.
It's going back. Same thing, bro.
Yeah, it won't come out the same. Okay. And then from A to C, I didn't label this one. We're going from 1 to 0, so that's negative 1. And we're going from 3 to negative 6,
9.
negative 9. Okay, if you're not sure what it is, you just do the second x coordinate minus the first x coordinate. That'll give you the x component. The second y coordinate minus the first y coordinate. That'll give you the y component. Alright, then we're going to use those two vectors and do the dot product. I think I am going to make like one problem just like a plain old dot product. How do we do dot product? Do the x times the x plus the y times the y. So negative 3 times negative 1 plus 4 times negative 9.
Negative 33.
3, yeah, that's negative 33. Okay, and then for the magnitude of u and the magnitude of v, it's Pythagorean theorem basically. So negative 3, 4 means this vector, but you're going to find the length by Pythagorean theorem. 3 squared plus 4 squared equals 25. Square root of 25 is 5. Okay, for v it's 1 squared plus, the negative doesn't matter because negative 1 squared is also positive 1. 1 squared plus 9 squared is 82, square root of 82. Okay, that doesn't come out nice. It doesn't really matter if you simplify this. In this case it doesn't simplify, but because this is not the answer. We're trying to find angle A here, so how do I find angle A?
Just an inverse.
Yeah, cosine of A equals all this. So that means we need to plug in cosine inverse of all that stuff.
136.8.
See if we got it right. Yes, we did. Okay. Alright, you guys got that one? It is multiple steps. You have to know to find the vectors. You have to know how to do dot product. You have to know how to do magnitude. You have to know to plug in cosine inverse. So you got to know a lot of stuff on that one.
This is not very nice.
So make sure you show your work. That way if you get one step wrong, I don't have to take everything off.
Get back. So sunny now.
Whoops, what am I
It's
doing?
so sunny now.
It's nice.
It's supposed to be like 70 today or something.
I hope so. Hopefully.
Nobody knows.
Yeah, do you need me to help you?
Okay, Trey.
Thanks, bro. You can't just grab his pencil.
I thought you were just gonna kick it over.
Is it that hard, man?
Yeah.
You know what I thought of when you slapped Trey's legs? May I?
Yeah.
You didn't ask that time.
No, I just did it.
Yeah, people over Sam was so weird.
Bro, I didn't think you
I was weirded out.
You said, fine.
He thought you were going to pick up his
Yeah, I
pencil.
thought you were picking up my pencil.
He's in for a rude surprise. Okay. Okay. Number 8. We are at the 3D thing. How do we find the length between 2 points?
The same thing as normal length.
Okay, the distance formula, but the 3D version. So the normal distance formula was x minus x squared plus y minus y squared. But since we have a third coordinate, now it's plus z minus z squared. I don't know how they figured out that worked.
Q squared is
putting pluses because some of these were negative. So let's see, that's 104 and 4. I only got 108.
Square root of 1.
Yeah. Which would, oh, that does simplify, yeah.
6 squared, 3.
It's -5 minus
Oh, I wrote down the wrong numbers. Darn it. Okay, now that's a lot bigger.
248.
Okay, what's the square root of 248?
No.
2 squared, 62.
2 squared 62. Yoink. Okay, that's the A. That's usually the sound effect when you're stealing something. Yoink.
Isn't there a guy online that says while stealing?
You have to add sound effects.
There's a guy in like Florida that will go up to
Like
random
Easton
animals and
has
just
it.
go,
Yeah.
yoink.
Does Easton say yoink a lot?
I don't know.
Eat.
Just grab snakes. And
Yeah, and he's perfectly fine.
perfectly fine.
Okay, the other question is midpoint. So how do we find the midpoint of 2 points?
Add together and divide by 2.
Right, you average the coordinates. So it's x plus x divided by 2, y plus y divided by 2, z plus z divided by 2.
He does it.
So 4 plus -6 is -2 divided by 2 is -1. 0 plus -2 is -2 divided by 2 is -1. -5 plus 7 is 2 divided by 2 is 1. Alright.
So close to being able to
I think,
cut Fridays.
guys, I'm not going to give these formulas to you on the test. Because in the past I've made you memorize like the normal distance formula, the normal midpoint formula, so you just have to add the z coordinate on, so I don't feel like that's a big ask. All right. We didn't do number 9.
Do we skip it?
Skip it. Skip it.
You say upward. 2.
What do you do that to yourself?
Then drink a bag of like 10. That was a bad decision.
I'm in bed by 10. each
Or
night.
10.
So we're done?
Oh, wait, we did 10. Yeah, never mind.
We did 10.
Yeah, I think
We only have 10 minutes.
I must have changed this test quite a bit from what they wrote in the chapter test. Okay, number 10. You guys remember the sphere thing? So, on a 2-dimensional graph, a circle equation usually looks something like x minus 3 squared plus y plus 2 squared
Oh, yeah.
equals, 25. Okay, that means the center of the circle is at positive 3, negative 2. And the radius of the circle is the square root of this number. 5. Okay, so on 3D it looks almost the same. A sphere is going to have the same kind of deal. So it says find the equation of the planest. Oh, we didn't do tangent though. With equation, blah, blah, blah. Okay, well, it's not too much different than what we've done though.
Would it just be 1 over 33?
So, what we actually did on the homework, let me see, what's that point? 2, negative 3, negative 2. Call this 10. We did something similar to this. This is the one we just graded, isn't it?
Yeah.
2, -3, -2. What we did on the homework was we said if that is a perpendicular vector, and if you have a plane, I can't draw it, that's tangent to a sphere. You guys remember what tangent means?
Isn't it like right against and it's not going through?
It like touches at one point. I don't know how you draw it, but
Just like that.
like it barely touches at one point, basically is what tangent means.
That's what
Um,
That's weird.
yeah, forget it. We didn't do this problem. It doesn't matter.
it's-
Okay, but hold on. I do want to replace it though. So, because we did do problems kind of like this on the homework, and I probably put it on the test. So, 2, -3, -2, if that's a vector tangent
Could you plug it in?
to the plane, then what we did, this is the one we just graded, is this. You guys remember that?
Mm-hmm.
And then to find, remember how we found this number out here?
Plug it in. Yeah, you plug it in.
Okay, well, they gave us a point that was on the plane. Like, I'll just make something up. Let's say it's like 4, -1, 2. Let's say that was on the plane. So if that's on the plane, when we plug in 4, -1, and 2, it should equal whatever this number is. Okay, so this is a vector that is perpendicular to the plane. Girls? And, oh, it's not there. So that's how you get those, and then you plug the point in that's on the plane to get this. I really wish they would use different symbols for vectors like this. They're a little bit out of date there. And if I plug that in, that'd be 8 + 3 is 11, minus 4 is, it'd be like 7.
So you were doing 10 or?
That was 10.
No, that was my replacement of 10.
Okay.
So we just put that